Well, welcome to this online revision session for AQA D1, in which we're going to look at the January 2010 question 3 on the topic of linear programming. Well, you can see in this particular question we are actually given all of the inequalities that are required for the problem that we're going to investigate, and in the first part of the question we are asked to represent these inequalities on a suitable diagram indicating the feasible region. Okay, so for each of these regions we need to draw a line. So for example, for x greater than or equal to 0, we draw the line x equals 0, or y greater than or equal to 0, it's y equals 0. Or for x plus 4y less than or equal to 36, we draw the line x plus 4y equals 36. So we remove the inequalities to draw the equality, and then we will shade out the piece that is not required. So here's one I did earlier. You can see I've drawn some of the lines already on this diagram. So for x greater than or equal to 0, we know the x-axis is running horizontally, so x greater than or equal to 0 is what we require, so less than 0 has to be shaded out. So strictly speaking we need to shade out this part that's not required, and similarly for y less than or equal to 0 we should, strictly speaking, shade this out as well. Now, as we can see, it's quite possible that our lines may well contain what we require anyway, but until we've actually sorted out the shading we don't actually know that. Okay, so for the line x plus 4y equals 36, you could see that when x is 0, y is 9. So that's that point here on the graph. Similarly, if x is 16, x is 16, then y would have to be 5 to make that 36. So that would be that point there. 2 points is sufficient to draw the line. You might want to calculate another one. For example, that one there would be 8, and then y is 7, so x is 8, y is 7, as another check. Now we want this, the region we require is less than or equal to 36. So for example, if we put 0, 0 in, obviously 0, 0 is less than or equal to 36, so this point is on the correct side of my diagram, so the piece I need to shade out is above that line. When you shade it out, just cross-hatching is all that's required to indicate that, and it's a lot quicker than shading solidly, and it probably looks a lot smarter when you've finished because you can still see the lines clear. And it is well worth actually labelling these lines, so label it x, x plus 4y equals 36, so you know what that line is. So similarly for 4x plus y less than or equal to 68, if y was 0, x would have to be 68 divided by 4, which is 17, so that's this point down here. And this line we can see has a gradient of -4, so we know that if we go 1 back it's got to go 4 up, 1 back, 4 up, so you can see where this line's going. So again, label this line, and this time the shading, again if you put 0, 0 in, 0, 0 is less than or equal to 68, so 0, 0 is on the correct side of the line, so the side of the line to shade out is over this side. You then have y less than or equal to 2x. So if y equals 2x, so if x is 1, y is 2, if x is 2, y is 4. So that's a relatively straightforward line to draw in. This time you can't use 0, 0 to check on the side of the line. So choose another point like x is 1, y is 4 for example, and if you put x as 1 and y as 4, is 4 smaller than 2 times 1? The answer is no, so this is the wrong side, so this side is the right side, so we shade out the wrong side. So that's the side we need to shade out. And then finally, on y equals 1/4 of x, so if x is 4, y is 1, if x is 8, y is 2, and x is 12, y is 3. So this is the line we need to draw here. And again, it's quite simple, just take a point, so if x is 2 and y is 0, is that the right side or the wrong side? Well, if x is 2 and y is 0, y is not bigger than 1/4 x, so that's the wrong side, so this is the right side, so we shade out the wrong side. Now the question asked us to indicate the feasible region, so the feasible region is the part that has not been shaded, not being crossed out, so it's this piece in here, so it's probably just worth putting an arrow to it and labelling it feasible region, so the examiner's clear that you know exactly what you're doing. Okay, so where do you get your marks? Well, you pick up a mark for being correct with each of your 1, 2, 3, 4 lines. Okay, and for actually having both of these lines going within 1 square of here, it's important that you draw these points accurately, these lines accurately. Okay, so the better you draw this, the more attention to detail, the better. And obviously you get a mark also for your feasible region. So there's accuracy marks for the 4 lines, labelling, and then a method mark for knowing how or what you're doing in that particular section to give you your 6 marks. Okay, we'll probably come back to that diagram in a moment. Now the next part says use your diagram to find the maximum value of P, stating the corresponding coordinates on the feasible region in the case where. Alright, so part 1, P has got to equal x plus 5y. This is the thing that you are trying to maximise, what you might call your profit if this was in a specific problem. So if we look back at the diagram, the key thing is the vertices on the diagram. If you remember, the vertices are where the maximum or the minimum, depending on what we are doing, actually occurs. Since we're maximising, the 0, 0 is very unlikely to give us a maximum, though it might do, depending on the function. But these 3 are key. So we have a coordinate here of 4, 8, a coordinate here of 16, 4. So let me just write those down. We've got 4, 8, 16, 4, and then the third coordinate is about 15.7, 5.1 approximately. So it's 15.7, So what we can now do is to work out this value of P for these coordinates. So for example, if x is 4 and y is 8, 5 eighths are 40, so this gives us a total of 44. If x is 16 and y is 4, that's 20, that makes 36. On this one we get 15.3, added onto that makes 16 and 15 makes that 31. So we can see our maximum value there is at the coordinate 4, 8. So we can say the maximum is equal to 44 at 4, 8. So our 2 marks come from stating that value and stating the coordinate. Similarly, if we've got P equals 5x plus y, we can do the same for this one. So 5 times 4 is 20, plus 8 makes that 28. The next one is 5 times 16, which is 80, plus 4 makes 84. And this one, 5 times 7, 15.7. Well, 5 times 16 is 80. So we've got to take away 1.5, so that's 78.5, 78.6, that will make 81.6. So this time we can see that our maximum is equal to 84, and that is at the coordinate 16, 4. Once again, you must make that statement. Just doing a table of values without interpreting what that is showing is not going to be of any help to you. So again, you get 1 mark for that statement and 1 mark for stating the vertex. Well, hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.